Hello everybody, I'm Fred BRECHTEL, and today I'm going to show you how to set up a Model 9401 miniature 8-channel filter sampler that's typically deployed on mobile platforms like unmanned aerial vehicles, aircraft, cars, all sorts of different applications. What you're showing here is the main pieces of the system. This is how it's going to be delivered to you in a weatherproof case. We have here the heart of the system. This is actually the 8-channel sampler itself with the sample inlet up on the top. Then you can see the 8 different filter capsules, these white capsules, where the filters are held. And then down below here is actually a magnetically driven solenoid valve system that lets us connect one vacuum pump to this port to draw the sample flow through just one channel at a time. That's one of the unique features of the system. You can command it to only draw flow up to about 3.5 liters per minute through any one of these channels, depending on your sampling needs. This lead coming off here is to the stepper motor that's inside the middle here that rotates the magnet. Down here on the bottom you can see the rotation mechanism to open and close the various valves that are underneath here. The next thing you're showing here is the main control board. And in a moment I'll show you how all these items connect up to the main board. This is the control board running the onboard firmware that's responding to serial or USB commands to tell the chem sampler what you want it to do. This assembly here is a laminar flow element. This is a precise measurement of volumetric flow. The inlet is in this direction here, the air is flowing in this direction, and we're measuring the pressure drop across these two tubes, and we're measuring the local temperature on the LFE with this thermistor before the air flows into the chem sampler inlet. This is the small vacuum pump that's attached to the vacuum port on the chem sampler. This port is simply attached to this port with the supplied tubing that has designators on it for which direction the flow should go. And this is the 12-volt input cable assembly, which you'll plug into the board right here. So in this case, I've used the cable assembly that has the barrel connector that mates with the AC to DC power supply that's shipped with the unit. We have a second version of one of these cables that just has flying leads that you could connect to a 12-volt battery or some other power source. So it's very important that you connect the various items to the board in the proper way. These cables should be labeled. For example, the pump has connector 7, pump, and if I look at the board here, I can see connector 7 right here. Okay, so look at the board labels and you'll see connector 7, and make sure that you plug the pump into the connector 7 port, just like that, and you hear the snap, so it's engaged. Here is the stepper motor connection. The cable is labeled connector 8 stepper, and the board is labeled stepper motor. So here I'll just plug this in right there. Alrighty. Now this is the display. I didn't talk about this. This is the one way that you can interface with the software. And when it's connected via this ribbon cable to the control board, the firmware will display messages on here in a menu structure that you can navigate using this control knob to look at the various parameters and to set up your run. The thing to remember with these displays and these ribbon cables is that this black colored piece on the ribbon cable always faces the brown latch that's on the ribbon cable connector. Alright, so the black goes to the brown connector. You push the ribbon cable down into the connector square, and then you push down on the brown connector to clamp it in place. Okay, that's the way it locks in. So you can see now it doesn't come out if I pull. All right, so I'm pushing down on this brown latch on the ribbon connector, and that's what locks this ribbon cable in place. You can see the same connector is on the display board here. Okay, you want to be careful not to let this get caught, because that can cause the display and the main board to act strangely. Okay. Now finally, electrically at least, I want to connect the thermistor from the LFE to the correct position. That's labeled here, connector 2, therm. Therm is short for thermistor. And connector 2, the port is right next to these little mini pressure sensors. These are the little mini pressure sensors that will be used right here to read the laminar flow element. Okay, so I'm just going to click this right into place there. All right, finally, you need to make these tubing connections. You need to make a few different tubing connections, actually. First, let's connect. This is the downstream pressure, and it goes to PS1, pressure sensor 1, and it says upper. Okay, that means it's the upper port. Okay, you can see if I turn this here, you might be able to see there's an upper port and a lower port. And this one goes to the upper port, so you want to carefully stretch the silicon tubing over the barb and push it on securely. Okay, so you get a nice tight fit. Okay, and now for the upstream measurement, we're going to split this, and we're going to split this because we're going to use 1 as the differential pressure measurement. That goes on PS1, lower. Okay. And then the second one we actually use to measure absolute pressure. So there are two sensors. One's a differential pressure sensor. That's the one closest to the thermistor. And then this other one is just used to measure total pressure. That's important if you want to do STP corrections to your concentration data. Alrighty, so that's all the mainboard connections for right now. Now I need to finish my tubing connections. So again, the flow is going through the LFE in this direction. Particle flow is coming through here. And this just gets hooked up to the barb. Okay? On your platform, you'll want to support this somehow with a tie wrap, or lock down the LFE so it's not flopping around. Okay, now for the vacuum, I want to hook in to the vacuum outlet barb on the Chem sampler here. Okay, just like that. And then the other side of this barb just goes right to the vacuum pump input barb. Just like that. Your pump may not ship with this vent filter installed. This vent filter is just meant to reduce the noise from the pump. Let me leave it off for now, and you'll see how noisy the pump is. And if you can't tolerate it, we likely included one of these muffler filters, but you can put any filter on that outlet that you want, just as long as it doesn't have a high pressure drop at about 3.5 liters per minute. All right, so we're ready to actually hook in the power. Before I do that, let me mention a couple other things about the main board. If you look carefully here, right next to the power plug-in, you'll see a small mini or micro SD slot. You can store data locally on a micro SD card just by sliding it in, pushing it, and you hear a click. Okay, this will ship with your unit in the ship kit with a reader adapter so that you can plug it into a USB port of your computer. You also see here a USB port on the main board. That port is only used if you want to communicate with our LabVIEW user interface software that would typically be running on a ruggedized tablet like this. This is actually the 9400 base module for the access line. We'll be talking about that in another video. We also have RS-232 communications through this port, and a black connector to DB9 connector cable is supplied with the unit if you wanted to communicate directly with it via RS-232. Okay, so now supplied with your unit is a power supply that looks like this. It just plugs into the AC wall and has a 12-volt output side here. Alright, so I'm just going to plug that in here to get the power going. Okay, so let me see if I can get this. So you can see the Chem Sampler software has been configured to automatically turn on. Okay, that's a setting that can be set in the defaults menu. Alright, you don't have to have it come on automatically. You can set it to do that depending on your own sampling needs. So now you can see if I install this filter, that quiets down the pump quite a bit. So let me see if I can scoot this a little bit closer here so that you can see what's going on. So let me just trace the airflow again for you, just so that you're sure to understand what it is that's going on here. The sample flow is coming through the LFE here. Okay, so this is what you would hook to your inlet, your sample inlet going to the outside. The particles in the sample flow, typically between about 1/2 and 3.5 liters per minute, is coming through the LFE and going into the top of the sampler. Here there's a distribution plenum that distributes the flow to only one of these channels at a time. So only one filter is actually getting airflow at any given moment. The airflow passes through that filter, it passes through a valving system in the bottom, and then it comes back up this exit tube all the way around to the vacuum pump. We have a ballast tank here that prevents the pulsations from the diaphragm pump to propagate back into the system. That helps keep the filter steady. That's pretty much it. So the two basic modes for running the Chem Sampler, one is called interval mode, where you pre-program the amount of time you want the unit to spend per filter, and it automatically begins sampling at station 1, position 1, for that amount of time before it automatically advances the flow to position 2. And then it goes that same amount of flow at position 2, and it just keeps going all the way to position 8. So that's called interval sampling. The second way of sampling with the Chem Sampler is in I'll turn it off for a second here, is what's called manual mode. Okay, so in manual mode, I can set the position I want. I just changed it to position 2 by rotating the knob here, and then I can turn it back on again. Okay. So by clicking in the button, I'm selecting different selection spots and going between different panels. So let me see if I can figure out a way to display the front panel readings so that you can actually see them. I'm not sure I can do that very easily with this video setup. I think I need to find a different video configuration here. Okay, so I'm going to briefly show you what the Chem Sampler interface looks like in the user interface software. So if you purchase the Access base module, the Model 9400, you're going to get this ruggedized tablet here. Okay, this is a special tablet that's got a much broader temperature range and much more resistance to shock. It meets military specifications, so it's going to withstand the G-forces and whatnot in your mobile platform. So the power button's up here. You'll push the power button, and if you want to get into the user interface, you just swipe up. It should bring you right to the desktop. Okay, you'll have also been supplied a USB hub that you'll plug into the USB port on this side right here next to the Intel button. And what you want to do is you plug in the supplied USB port, the USB cable that came with the Chem sampler in the ship kit, and you plug in the mini USB connector into the mating USB connector in the control board, and you'll hear that recognition ding on the tablet. Okay, there should be a shortcut on your desktop to the UAV reader software. We're currently shipping version 4.0. You can use the stylus. The stylus is the best way to interface with the tablet. Just double click it, and then you can move the window so it's centered, and you can see that the software has automatically recognized the Chem sampler, serial number 6, and file saving to the tablet is set to off. Let me just turn that on. Okay, so file save is on. Now, if you look, this one piece of software is actually meant to interface with our UAV mixing CPC, the mini OPC, the STAP, which is an absorption photometer to measure black carbon, and the Chem sampler. But you'll see that the Chem sampler interface is the only interface that's live right now. All of these other interfaces are grayed out. That's because these devices are not currently connected. Okay, if you connected any one of these instruments to the same hub, then the software would automatically recognize that those instruments have been installed. In this case, all we have is the Chem sampler. Okay, and you can see it's saying that Chem sampler is on, that the mode is interval sampling, it's in position 2, and it's already in its countdown sequence with an interval period of 7,200 seconds. So it's telling you what the pressure is it's reading, 1,007 millibars, the temperature is 29.7 degrees here on the sample thermistor, and it's telling you what the measured sample flow is compared to the flow set point. If you want to look at more details about the Chem sampler or any of the other connected instruments, you would just come here to Chem Details, click this tab, and you'll see all the current diagnostics readings, if there are any errors, what the pump power is, the supply voltage. You'll see the calibration coefficients. Do not change these unless you recalibrated the sensor. You'll see the time and date. That's current, well, not currently, but that was last recorded by the Chem sampler. You need to push that button if you want it to update these readings, okay? And then here's manufacturing info with firmware, manufacturer year, etc. Okay, so normally you would be looking at this and you'd say, oh, it's at current position 2, I've got 6 more to go. What's the flow rate? What are some of the other operating parameters? And you can actually, you can turn it off right here. Sometimes the stylus is a little bit picky. You can see it went off, see the flow has gone to 0, and I can turn it back on again. It automatically continues where it was unless you fully cycle the main board power. All this all this button does is shut down the local power on the that drives the Chem sampler itself, but not the firmware on the board. All right. So if you have any other specific questions about the Chem sampler, feel free to email us at the email provided at the end of this presentation. Happy sampling!